Okay, so here I'll present another solution. I came up with this because I was really annoyed by this kind of case when I also answered myself in the contest. So I thought of a way that is more graphically intuitive. So let's label the line here. So you have something like this. So we know that if we don't have any conditions that reaches for within the first 8 moves, the entire what's it called, the
Number one.
It's the entire distribution. The entire distribution will follow something like a Pascal's triangle. So first of all, we start with 1, and then we have 1, 1. Actually, these are 1/2, 1/2. So I'll omit the denominator for now, and then we just divide the powers of 2 at the end. So I have 1, 1, and then we have 1, 2, 1.
So this is like the probability that you reach each place after some number of moves.
Yeah, actually the number of ways, the number of
Right.
permutations, yes.
So the first row is
So-
no moves. Next one is in
1, 1, and then this is 1/4, 2/4, 1/4. Yes.
moves.
So we continue, and now we consider the problem statement. Instead of reduce 4 with the first 8 moves. So here we already made it. So here's the twist. So once we reach here, we do not make this number go downwards anymore. So we basically remove this number from the triangle.
Right. You break it.
Yeah. So at this point, you can see that the numbers this part doesn't matter because you cannot reach that anymore like in time. So let's just write here roughly. So this is 4, this is 10, this is 10. I don't care about this side anymore. So this is 14, this is 4. 4, here I made it. This is 6 moves. This is 4 moves. This is 6 moves. So here I remove 4. Here's 20. This is 34. 14. Here's 48. 14. Here, this is 8 moves. So in order to add the probabilities, we need to divide this by 2 to the 4, this by 2 to the 6, this by 2 to the 8. And hey, we get exactly the same thing we have here. So essentially this way is equivalent to this way, except that we reduce a lot of casework by just running numbers.
What do you want to say?
Yeah, I can say also the way I thought. You guys thought how many moves I can get. I thought about it, how many ways I go to the right or to the left, right? So I have 8 moves. To reach 4 times to the right, what are my possibilities? I can have 8 moves to the right. I can have 7 moves to the right, 1 to the left, 6 to the right, 2 to the left, 5 to the right, 3 to the left, 4 to the right, 4 to the left. These are only chances I get to the point 4 from 0, right? Now, the interesting observation that in all these top 3 cases, I always reach the point 4. Because if I move 6 times to the right, 2 times to the left, I will always get to the 4. And in the bottom case, 4 to the right, 4 to the left, I can reach 4 only if my first 4 moves are to the right and the next 4 are to the left, right? So there is one configurations for this. There is one choose 8, which is 8 configurations for that. 8 choose 2, which is what?
28.
28 for this. And this is 1, right? So the hardest case when I was working on it, I realized if I can find how many such sequences with 5R and 3L, I'll be done.
Yeah, that is very similar to Vinjay's earlier approach now, because this you have to do some exclusion, right? You have to do some cases.
This one, yes.
Yeah.
But with he thought how many moves he does. I have no overlap.
Right, but what I mean is the 5R 3L case, you have to deal with cases now.
But it's still much easier,
Right? Yeah.
Yes. So 5R 3L it means my first.
Well, how would you not be able to get to the 4? Right, like
If you have 2L in the beginning,
2L in the beginning and
you have 2L appears before the 5R is completed, right?
Yeah, this is a tricky one because
so out of the first 6 numbers are the key, right? So out of the first 6, you either have 1L and 5 R's, or you have the first 4 R. Right? So that's the 2 cases you need to be careful.
so I'm going to write down what you said. So either the first 4 are my R's,
Yeah.
and here I have 3 L's and 1 R, right? So there are 4 such sequences. Or I have an L among the first.
6.
So you have 5 R's and 1 L, so you'll still reach there.
Yeah.
But the L needs to be among the first 4 because
L must be in the first 4, right?
because we don't want to overlap between the 2 cases.
And my last 3 must be R's. In the first 4,
So the first
I
4
must
you have 1 L and 3 R's.
and now
Yeah.
3 R's.
And then your next 2 are both R's.
So here I have 1 L or 3 R's, right?
Your next 2 must both be R's.
And the next one,
So the next 4 must be RRLL.
Because your only shot, right, is if you have 2 L's in the beginning, there's no way you can make it because you need 6 R's to get to 4. And you don't have 6, so you have 5.
Oh, it's RRLL.
RLL.
RRLL.
So this is the only way, right? And there are 4 sequences like this, so we get 8.
8 total.
Yeah, so when we add up, we get what? 1 plus 1, 2, plus 18, 28 plus 18,
Yeah, 46 over
46.
46, right?
over 256. We see the same.
And you simplify it and you get away.